Hello! In this example, we're going to go through an independent samples t-test and how to analyze the data in JASP and then write up the results accurately for APA formatting. So for this example, we want to know, is there a difference in test scores between students who attended the study session and students who did not attend the study session? So we've got the people who did not attend the study session, and then these were their test scores. And then we had the people who attended the study session, and here are their test scores. So what statistical test should we use? Form an appropriate hypothesis, run the statistical test, and then write up the results. So an independent samples t-test should be used because the data we are using, first of all, is two groups of numeric non-paired data. So it's not paired. The data is numeric, and we're wanting to know if there is a difference between these two groups. So we want to know if there's a difference, which independent samples t-tests are good for looking at if there is a difference between two groups that are independent, so not paired, and the data is numeric. So we are good to go for this is the correct test. Our hypothesis is going to be there is no difference in test scores for students who attend the study session. That's our null. An alternative is that there is a difference in test scores. We're then going to run the test. Now, I will say, similar to the chi-square, it's not as easy as the correlation. We can't just quite as easily copy and paste. So we can do some copying and pasting, but it's not quite as easy. So let's come back up here and let's go ahead and get it created in JASP. So here is JASP, and we're going to go ahead and do new data. And the first thing we're going to do is, let's see, what was that? I think it was study session. Yeah, so this one is, and I just double clicked on there, study session. Okay, and that's going to be just a yes or a no. And then this one is their test score. Okay, so the way we have to organize the data in order for it to work in JASP is that we've got our categorical variable. So even though this might look like here's our two variables, did not attend, did attend study session, that's actually not the way the variables are set up. So the way these variables are actually organized is that we have one categorical variable, and the one categorical variable is whether or not they attended a study session or did not attend a study session. So we have one categorical variable with two options, attended or did not attend a study session. We then have one numeric variable, and that is their test score. So that's these test scores. So one variable is just right here, did they attend or not attend a study session? And the other variable is the numeric variable down here. So don't let yourself get kind of confused by, well, it looks like this is a variable and this is a variable. Those aren't variables. The variables are actually if they attended a study session or not, and then the variable is their score. That is how we have to set it up here. So we've got study session, and it would be yes or no, and then it would be test score. Now the easiest way to do this is to go ahead and just copy that information. So go ahead and copy that. And right here for test score, we're going to paste that in. Then remember, these are all the no's. So we're going to go ahead and just do no. And then once you have that there, if you want to copy it and then just paste it in. But these are all the people who did not attend the study session and their scores. So double check, did not attend 60, 63, 75, 70, 76, 60. Okay, so we have all of the test scores for people who did not attend, and we have that they did not attend. Then we're going to go ahead and copy the people who did attend the study session. And they're just going to go right after this. And it doesn't matter. You could do yes first and no second. The order does not matter as long as you've got the data separated into these two columns. And then you can just make all of those yeses. The big thing is that you want to make sure all of your yeses are spelled correctly and all your no's are spelled correctly. So basically when you click study session, you want to make sure there's only two answer options, a no and a yes. If there's a third one, then you know you got something messed up, so go back and double check it. But we do have all no's and then all yeses there, and we've got the test scores. Double check your yes test scores. So that was at 74, 76, go all the way through, yep, and 82. Okay, once you've double checked your data, make sure, come back up here, and make sure to save it. So make sure to save that data. Then double check once again. We do have nominal, so that's just that yes, no. This is just an categorical variable of yes or no. But then we have test score, which is that scale/numeric data. So we are good to go. We've got to have our data into JASP, and we are ready to analyze it. Now to analyze it, we're going to go ahead and click this analysis button and go up to t-test and independent samples t-test. So this is where we go right here. Now for our dependent variable is that numeric variable. In this case, that is the test score. That's the thing that we think is dependent on the grouping variable of whether or not they attended the study session. So right off the bat, we get our initial independent samples t-test results, but we need more than that. So we're going to go ahead and we're going to do the assumption checks for normality and equality of variance. And so these are our assumptions to make sure that our data is data that will work for this independent samples t-test. Because remember, just because we have data and it technically will work for an independent samples t-test doesn't mean that it will meet the needed assumptions for the t-test. So we got to do normality and equality of variances. We also, underneath additional statistics, we're going to check the box for effect size and Cohen's d, because this lets us know just how big, if there is a difference, how big of a difference there is. And then we also want the descriptive statistics. And the descriptive statistics are going to let us know the mean and the standard deviation for our two different groups. So we now have all of the data we need. So make sure you open your, oh, there it is, sorry. Your little snipping tool, and what you're going to want to snip is this independent samples t-test and Cohen's d information. You're going to want the Shapiro-Wilk information. You're going to want the variances, the test quality of oh shoot, you do not want Forrest-Brown or Brown-Forsyth, you want Levine. Sorry. Oh, I'm sorry. I'm so glad I caught that. So for the equality of variances, you do need Levine's. You do not want Brown-Forsyth. So make sure you're doing Levine right there. And then you do want to go ahead and grab your descriptive information. So basically all four of these things is what you will need to make sure that you copy and then paste into your Word document. So once you have all of that information, we can come over here and review the statistical results. So once again, we only needed mean and standard deviation from the descriptives. For the assumption checks, we're looking at that p-value for Shapiro-Wilk and the p-value for Levine. For the independent samples t-test information, we do want that Cohen's d information, as well as we'll be using the t, the degrees of freedom, and the p. So those are all of the different pieces of information that we will be using for our results. So the first one, oh shoot, I just realized this is out of order. Whew, okay. So the first thing we're going to do is look at our assumption checks. So that just lets us know, is this data appropriate to even use for the independent samples t-test? So how to interpret the Shapiro-Wilk p-value? This is going to be the exact same as when we were doing the correlation. So what we want is a big p-value. It's because we want the data to be normally distributed. In this case, our p-value is much bigger than 0.05, so that means the data is normally distributed. So yay, we got what we wanted. We are good to go. So Shapiro-Wilk's p-value is good to go because the data is normally distributed. For Levine, it's very similar in that you want that big p-value. So Levine just checks whether the variances of two groups are approximately equal and used to test the statistical assumption of homogeneity of variance. Once again, unlike the interpretation of a normal p-value, you want that high p-value for Levine, which indicates the variances are not significantly different, because you don't want the variances to be significantly different, because that basically variance is very similar to standard deviation. You don't want there to be a huge difference between those two scores, between your variances, which is just basically how much difference there are between the values. In this case, we have a p-value of 0.280, which means our variances are not significantly different, which, yay, is what we want. So we are good to go. All of our assumptions have been met. we are green light to move forward. So the next thing is how to interpret the t-test p-value. And so that is this p-value right up here with the independent samples t-test. It is less than 0.001. And what that means is that we get to reject the null because that p-value is less than or equal to 0.05, so we can reject the null. That means that we do have significant results. Determining degrees of freedom. So we're kind of cheating with the degrees of freedom just because, I mean, it's n minus 2. So we knew that we had, 9 plus 8 is 17. 17 minus 2 is 15. But nicely enough, for the independent samples t-test, they give us the degrees of freedom right there. So we are actually already provided our degrees of freedom, which is 15. And then how to interpret Cohen's d. Cohen's d is a standard way of measuring effect size for the difference between two group means. A p-value can let you know if there was a difference. So this p-value right here, this p-value says we do know, because if we're rejecting the null, we know there's a significant difference. So we know there's a difference, but Cohen's d will tell us how big that difference is. So we know there's a difference. We don't know how big that difference is. So if we look at our Cohen's d, it is negative 2.768. And if it is negative 0.51 or lower, which negative 2.768 is definitely way lower, that means it is a large effect. So we do have a large difference. Okay, so now we know that our assumptions have been met. We know we have significant results. We know our degrees of freedom. We know we have a large effect size. We just need to put all of that into some written results. So for the written results, independent samples t-test was performed to determine if there was a difference in test scores for students who attended the study session and those who did not attend the study session. We have our null hypothesis that there is no difference. We have our alternative hypothesis that there is a difference. That Levine test found that the assumption of homogeneity of variance was met. Make sure to include that p-value. A Shapiro-Wilk test showed that the groups have normally distributed data. Yay! Give that p-value. And so then you're good to go. You can move on and say it was determined that there is a significant difference between students who attended the study session. And so this is where you include the mean and the standard deviation for those who attended this study session. And that was right here, mean and standard deviation for those who did not attend the study session, and mean and standard deviation for those who did attend the study session. So you include that. Make sure, once again, italicize all important statistical letters. Don't use leading zeros. So there was a significant difference between those who attended the study session and those who did not. Include that. Then we've got our t-value. So t, then our degrees of freedom is equal to, then we've got that t-value, our p-value. Once again, italicize the p, do not including a leading zero. The null hypothesis was rejected. Very important. Make sure you say that the null hypothesis was rejected. Then Cohen's d, and include that Cohen's d information, suggests that this is a large effect, with those attending the study session getting significantly higher test scores than those who did not attend the study session. So that is your written results. And then I also went and included non-significant results. So just in case you get non-significant results, this is how you would write it up. This information is all the same. This information is even the same. The only difference is starting right here. So it was determined that there is no significant difference between students who attended the study session and those who did not. And so you can see that the no significant difference is coming from that p-value. And also remember, this is my pretend one. This is not real. This is just some made-up data, so you have an example of how to correctly write it up if the results are not significant. We fail to reject the null hypothesis. Cohen's d suggests that this is a small effect, with those attending the study session getting higher test scores than those who did not attend the study session. So I hope this helps, and if you have any questions, let me know.